Hi everybody, and welcome to this tutorial on fracture topology in WellCAD. In this tutorial, we will take you through the different functionalities associated with fracture topology in WellCAD. This video is structured in 3 sections. The first section will cover the interpretation process. Something is very important in fracture topology, and that is the determination of the type of nodes. They refer to the interaction of different types of structures between each other. You can see in this example of the OBI of my dataset that there are nodes with different colors. These are in red, blue, and green. Secondly, we will cover the various statistical outputs in 1D format, but they can also be delivered in a ternary plot format. And finally, we will cover the statistical output that WellCAD can also deliver. So going back to the first part of this tutorial, which is the interpretation process. To understand the meaning of the nodes is required for the interpretation in WellCAD. We will use some supporting material for further explanations. So we can consider this fracture as an insulated one. Isolated fractures are displayed with green nodes. They are partial structures that do not connect or interact with other fractures. We also have intersecting fractures, which are represented by blue nodes, as we can see here in the slide. These are crossing fractures that form connections with other fractures. And finally, we have these red nodes. These are terminate fractures, and they also refer to those fractures that terminate at other fractures. So the user picks out the different types of fractures, and the WellCAD software will assign a different node, red, blue, or green, depending on the relationship between the fractures. We can proceed now with the first part of this tutorial, which is the picking of the structures. You can see in this OBI dataset that many have already been picked. But if we go to the lower part of this well bore, there are fractures that have not been picked. So now we proceed to pick these fractures. They will have different types of nodes. The first fracture that we will pick is this one. So I will proceed to pick by pressing the Shift key on the keyboard and press the mouse button several times to get the best fit until we are satisfied. And then we can see this other fracture over here and an intersection which will be here approximately. And the WellCAD software will assign the blue node, which refers to an intersecting feature. We can see another relationship between these fractures and this fracture. This is a very nice example of a fracture terminating at another fracture. We proceed with the interpretation of this fracture. And then the other fracture. And when we are done with the second fracture, we press P on the keyboard for a partial fracture. And now we have 2 nodes that we need to adjust to the place where they intersect. When that happens, the nodes become red. This is a good example of a terminating fracture. And we can see another fracture which we can identify as isolated. So the way to interpret it is again creating a continuous fracture first. And once we are satisfied, we press the P button on the keyboard and we create a node on the place where it finishes. And then 2 nodes will come up in green for isolated fractures. So these are 3 types of nodes. Once the interpretation process is finished, the user is satisfied with the definition of the nodes in the borehole, and we can proceed to the next step. So we go to the process bar, Easy Module, Structure Logs, and Structural Interval Statistics. Here, 2 new sections have been enabled. This is the PXY statistics and the topology. For the first exercise, we will select only the topology related statistics. That is the node distribution, the number of branches versus the number of lines, branch connectivity, branch distribution, and line connectivity. Once they are selected, we press OK. Different outputs have been calculated as 1D logs. The user will have to arrange them to visualize them in a better manner. Once we have them arranged and organized, the scaling has been changed according to our preferences. We can observe specific relationships at different sections in our wellbore. We can also extract statistical output in a ternary plot format. To do so, we go to Edit, Insert New Generic Log, and we open a new polar and rows log. We have a new log, and we can select different depth intervals where we want to do the analysis. So in this case, I will select 1 interval in that upper part of the well bore and 1 interval in the lower part of the well bore. We can then select a different type of diagram, in this case node distribution. We select the data source, in this case the apparent pics with nodes, and we select all the different types of structures and then press OK. So now we have a point in the diagram which refers to type of topology that exists in the lower and upper part of the wellbore. With respect to the I mode, isolated the X mode, the cross-cutting fractures, and the Y mode and the terminated ones. We can also enhance the display with the legend, other overlays, in this case for the NB over NL, which is number of branches over number of lines. We can also select the overlay for the number of lines or the overlay for the number of branches. This gives us different types of statistics with reference to the type of geology or topology existing in our wellbore. This is the ternary plot for the node distribution, but we can also display the branch distribution plot, which delivers additional statistical information about our fracture topology. Again, we can customize it in terms of the data source. In this case, we will leave it as it is. We can also modify the title, interval depth information, legend, and overlays. In this case, with information about the number of branches. And again, it will inform us further in conjunction with the 1D log output, the statistical output that we already extracted. We can now proceed to the third part of this tutorial, which corresponds to the extraction of the PSY statistics. We can select all these logs and hide them so we have more space for the new output that we are about to calculate. We are going to go to Process, IC Module, Structure Logs, Structural Interval Statistics. We can calculate the P10, the P11, the P21, P32 and P33. This is the output we can generate in the PXY statistics. We press OK. And we have all the different output logs calculated for us. We can now arrange our template. We can now evaluate better the PXY statistics with respect to our wellbore, and we can indicate differences between these 4 different sections in our wellbore. The next step will be to export these PXY values to third-party software that will allow us to perform the fracture network modeling. For example, discrete fracture network DFN. Thank you for attending this tutorial for fracture topology. We hope to see you in our next video.